This video is going to cover section 7.1, the first subunit of Unit 7, Systems of Equations and Inequalities. We're going to start with linear and nonlinear systems of equations. We have a few definitions here. And just so you know, this is something you have seen, so hopefully, it's not too difficult. We have it a system of equations is two or more equations that consist of two or more variables. And a solution to the system is basically the ordered pair that makes each of these equations true. So it satisfies both equations in the system. Okay, we're going to start with the substitution method, which is going to be our primary use for this particular set of notes. And for substitution, all we do is we solve one of the equations for one variable. So for example, x, okay? And then we go ahead and substitute that equation into the other equation so that we have one huge equation in terms of just one variable, okay? So we solve it. Once we solve it, whatever value we get for x or y, whatever it is we solved for, we take that value and we plug it into one of the original equations to solve for the other variable. This is also known as back substitution or back substituting that variable. And of course, the final step is just to check both equations with that solution to make sure that we are good to go. So we're going to jump right into an example. And again, this is something you have seen before. So here's example number 1. And what I like to do is I like to find the equation that doesn't look so complicated, meaning if you look at the first equation, x and y are by themselves, they just have a 1 coefficient. So this is probably the one I'm going to work with. So I'm going to take, let me color code just a little bit here. I'm going to choose this one for step number 1, and I'm going to solve for x. So x minus y equals 0. To solve for x, we add y to both sides. So x is equal to y. So something nice and simple, okay? Step number 2 tells us to go ahead and substitute this value, x equals y, into this one, okay? So I'm going to go ahead and do 5x minus 3y is equal to 6. And I'm going to plug in wherever I see an x, okay? I'm going to plug in a y. And you can, in this case, you could actually go either way. You can go with the y also because it happened to be the same thing. But it just depends on the equation. So let's go ahead and do that next. So 5x minus, oh, looks like I did it backwards. That's okay. So in this case, I'm going to plug in my y with x. So 3x equals 6. Okay, solve. So that's step number 3. So 5x minus 3x is negative 2x. Divide both sides by negative 2, and we get x is equal to negative 3. Okay, and then step number 4 says to go ahead and take this value and plug it back into one of these equations up here. So one of these two, remember these are kind of like our originals, to figure out what the other variable is. So I'm going to choose the first one, x minus y equals 0. And I'm going to plug in negative 3 into x, which gives me, let's see, negative y equals, if I move this over this way, I get positive 3. Divide both sides by negative 1, which gives me y equals negative 3 also. Okay, which should make sense because according to what I found up here, x equals y, right? Step number 5 is to go ahead and check both solutions. So for step number 5, I'm going to check that this is true. Okay, so I have to plug it into both equations. So there's the part where it's going to be a little bit of work here. So x minus y equals 0, and 5x minus 3y equals 6. Let's do this side first. If both of these are equal to negative 3, then I'll have negative 3 minus negative 3 equals 0, which gives me negative 3 plus 3 equals 0. 0 equals 0. We're good to go. Okay. On this side, I have 5 times negative 3 minus 3 times negative 3 equals 6. Negative 15, let's see, plus 9 equals 6. Negative 15 plus 9 is in fact 6, so we are good to go. Which means that our solution for this one So our solution, which is also the point of intersection, if you were to graph this, okay, I'm not going to graph it, but if you were to graph it, we'll do a graphing example in a little bit, would be -3, comma, -3. And I am going kind of fast because again, this is something you have definitely seen before, okay? But if you do think it's too fast, go ahead and pause where needed and go back and take a look. Anyway, that's it for the first example. Moving on. We have a word problem next. Okay. Here's an application where you might see something like this. A total of $25,000 is invested in two funds, paying 6.5% and 8.5% of simple interest. The total annual interest is $2,000. How much is invested at each rate? Okay, so what we're going to do is we're going to write a system for this one. So we're going to write a system first, and then we're going to solve it. Okay, so it looks like I have $25,000 is invested in two funds. So those two funds, let's call them X and Y. So there is my first equation. X plus Y equals $25,000. Okay, and each of those funds is paying, correspondingly 6.5% and 8.5% of simple interest, where the total annual interest, so the total of these guys is 2,000, which means one of these is with the X, one of them is with the Y, and those together give me 2,000. So equals 2,000. Now I'm going to go ahead and put these here, but make sure that whenever you're going into a formula here, you want to change these into decimals. So it would be 0.065x plus 0.0, ooh, I'm out of space, 0.5, 0.85y. Okay, something like that. Let me write that nicer. That looks kind of messy. So 0.065x plus 0.085y is $2,000. Okay, so these are my two equations that I'm going to be looking at based off of this word problem, okay, off of this application problem. So now what I'm going to do is I'm going to solve it doing the exact same steps that I did on the page before, starting with step number 1. So we're solving now. This is our system, just so we know what we did here. Okay, step number 1 says to solve one of these for X or Y. So I'm going to take that first one just because it looks less complicated. And I'm going to get Y by itself. So I'm going to subtract X from both sides. So I'm left with $25,000 minus X. Okay. Step number 2 is to substitute this into the other equation. So let me show you what I mean, because the first example was kind of an easy one, but now we have all of this is equal to Y. So I'm going to take all of this and plug it into this guy right here, into the other equation. So 0.065x plus 0.085, but instead of y, I'm going to put all of this, 1,000 minus x is replacing the y that was here, okay? And all that is equal to $2,000. And what this does is it gives us an equation where we can just solve for x, okay? With one variable, we know how to do that, okay? So let's go ahead and do that. We're going to solve for x here. We have 0.065x plus we multiply 0.085 times 25,000. So we're distributing. Let me go ahead and do that really quick. And I'm getting 2,125, okay, minus 0.085 times negative x is negative 0.085x, okay, all equal to 2,000. Okay, now we're going to keep solving, so we're going to combine like terms. So 0.065 minus 0.085x is going to give us negative 0.02x, okay, plus 2125. Let's double check just to make sure because it is after school and I tend to make a lot of mistakes after school. Yeah, we're right. So this plus 2125 is equal to 2000. Okay. We're going to subtract 2125 from both sides, which leaves us with negative 0.02x is equal to 2000 minus 2125 is negative 125. Okay. Divide both sides by negative 0.02. And let's see what that is. I'm getting $6,250. So this is going to be equal to X. Okay, in other words, that's one of the let's see, that's one of the investments that's of this rate. Okay, so the one that was invested for 0.065 is $6,250. Okay, we're going to go ahead and do the next part. So step number 3 is to take this number and plug it back into one of the originals. So I'm going to use x plus y equals 25,000 because that one's just easier, right? So 6,250 plus y equals 25,000. We solve by subtracting both sides by 6,250. Let's see what that gives us. 25,000 minus 6,250 is 18. Let's zoom that down a little bit. $18,750. Okay, so it looks like this is our x and this is our y. Okay, and now we're going to go ahead and I think I might have, oh, actually, you know what? This was step 2 and 3. My bad, 2 and 3. So this is actually step 4. And you don't have to number the steps. I'm trying to stay consistent. But step number 5 is just to check both of them. Okay, so let's go ahead and do that super fast also. We have our first equation is x plus y equals 25,000. So plug them in. 6,250 plus 18,750 equals 25 grand. And this is in fact 25,000. So we're good to go on that part. Okay, let's check the other equation, which is that longer one, 0.065x plus 0.085x equals 2,000. Okay, and I'm going to do the same thing. I'm going to plug these numbers. I'm going to write kind of small because I didn't give myself too much space here. So let me zoom in so y'all can see what I'm doing here. Focus that a bit. Okay, 0.065 times 6,250 plus 0.085 times 18,750. And supposedly this gives me $2,000. So let's check what this is going to give us. 0.065, I'm just using the calculator just so you know. 0.065 times 6,250. Okay, this one came out to 406.25. Okay, let me calculate this part now. 0.085 times 18,750 is 1593.75. And supposedly that equals $2,000. So we're just going to add these two things together. 406.25 plus 1593.75. So plus, and I'm just using the basic calculator here. Okay, and it looks like we are good to go. So we're done. And that means that these amounts are correct. So if you wanted to put it in graph format and you wanted a point, it would be 6,250 and 18,750. And this would be our solution. Okay, Kind of quick, I know, but this is not, like I said, it's not a difficult topic. It's just kind of a lot of steps. Let's try another one. So we have solve a system of equations, and this one's not as, I mean, I guess it's not as simple as the other one because we have, oh, sorry, I'm not moving the thing a lot here. All right, we have another example here, and this one is including a quadratic. So this is one of those nonlinear systems that I was talking about earlier, okay? So what we're going to do is we're going to do the same steps. So step number one is still to solve one of these for one variable. I'm going to choose this one again because it just looks easier to deal with than this one. So negative 2x plus y equals 5. I'm going to solve for y. So plus 2x on both sides. So y equals 2x plus 5, which means I can substitute this wherever I see a y. Okay, so for step 2, I'm going to do that substitution. So let's see. I'm going to take this equation now, x squared, and I'll go a little bit slower on this one, plus 3x equals 1. And I'm going to plug in wherever I see a y, I'm going to plug in that 2x plus 5. So right here. Okay, so that's going to be x squared minus, put this in parentheses since we have more than one term, plus 3x equals 1. Okay, step number 3 is to solve this. So let's go ahead and simplify and see what we get here. So this is going to be x squared, distribute the negative, so minus 2x minus 5 plus 3x equals 1. Sorry about the shaking. I'm not sure why it's shaking so much here. Okay, simplify. So we have x squared, negative 2x. So negative 2x and positive 3x is going to give us positive x. Okay, minus 5 equals 1. And here, some of you might get stuck and might not be sure what to do. Whenever you have a quadratic, generally you try to get everything over to the side of the quadratic. So what I'm going to do here next is move the 1 by subtracting, which gives us x squared plus x minus 6 is equal to 0. What do we usually do when we have something like this? We try to factor, okay? Which it turns out is our method in this case because I know that 3 times 2 is 6. Okay, one of them has to be negative because it's negative 6. So I'm going to make the 2 negative and the 3 positive because 3 minus 2 is that 1 that I want here in the middle. Okay, and then of course we just set each of them equal to 0, which will give us x equals negative 3 and x equals positive 2. Okay, and now you might ask, well, what happened here? We have two solutions now. We have two x's, so which one do I plug in? So the answer is we're going to actually do both of them. Okay, we're going to have 2 points of intersection for this system. And the reason that is because this is a line with a parabola. So if you think about it, if you have a U-shaped graph with a line going through it, you can have it cross 2 times. It can cross once on the bottom, once on the top, or vice versa. So that's why we are going to have two solutions. So for my step number 4, okay, I'm going to have to use a lot more space on this one. I'm going to plug both of these into one of the equations. So let's use the first one because it's just easier to deal with. So negative 2x plus y equals 5. And you're going to have two different substitutions going on here. Okay, so let's plug in the negative 3 first, which is negative 2 times negative 3 plus y equals 5. Okay, negative 2 times negative 3 is positive 6. Bring everything else down. Subtract 6 from both sides, so y is equal to negative 1. Okay, which means that these two go together, so negative 3 comma negative 1 is one of my potential solutions. Okay, Same thing on this side, but now we're going to plug in 2. So negative 2 times 2 plus y equals 5, which is negative 4 plus y equals 5. Add 4 to both sides. So y is equal to 9. Okay, which means that 2 and 9 are the other pair here. Okay, and we're almost done. You might say, "Oh, this is such a long problem." I know. They are long problems. They're not that difficult, but like I said, it's just a lot of work. So for step number 5, we're going to have to check, right? So let's just keep going with it right here. Step number 5 is the check. And we have to check both solutions for both equations. So we're going to check the first equation here first. So negative 2x plus y equals 5 first for both of them. Okay, so negative 2 times negative 3 plus negative 1 is equal to 5. That's what we're checking, which is 6 minus 1 equals 5. So it looks like we're good to go so far. So this one gets 1 check so far. Same thing here. Negative 2 times 2 plus 9 is equal to 5. That's going to give me negative 4 plus 9 equals 5. Negative 4 plus 9 is 5. So this one also gets 1 check. Okay. However, we have to check the other equation too. Okay, so over here, we're going to check the other equation, which was, well, I might need more room for that one. Well, we can do it. So x squared minus y plus 3x equals 1. X squared minus y plus 3x equals 1. And again, we're checking negative 3, negative 1, and 2, 9. So let's see. X squared is going to be negative 3 squared minus negative 1 plus 3 times negative 3 equals 1. Okay, so I'm just plugging these guys into here, which gives me 9 plus 1 minus 9 equals 1. 9s are gone. So far, so good. So this guy gets 2 checks. So there's my 2 checks right there. Okay, same thing on this side. So 2 squared minus 9 plus 3 times 2 equals 1. Again, I'm just taking these numbers and plugging them into the equation. So 4 minus 9 plus 6 is supposedly equal to 1. 4 minus 9 is negative 5 plus 6, which is in fact 1. So it looks like both of these check out, okay? Which means, and I'm going to do this super, super, super fast, but if I were to graph, if I were to graph this, and this is just a super duper quick sketch, okay? At negative 3, negative 1, and at 2, 9, so 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. So somewhere here, you have a solution of sorts. So you have a line going through here, and you have this parabola that probably does something like, I don't know, something like this. You could get pickier, but basically that's what this means, that when you graph these two things together, these are the two solutions, negative 3, negative 1, and 2, comma 9. Okay, we are almost done with this video, guys. I think we have one more example, and this is a super quick one because it's a graphical one. Okay, so here is a graphing method where you have to find the point of intersection, which again is the same as the solution. Here, let me zoom this out just a little bit here so you can see what the problem is. Okay, so we're going to find the solution by graphing. Sometimes you do have to graph them because this is really hard to solve, right? I mean, it's not that hard, but we're going to go ahead and allow some graphing ones. So what I'm going to do is I'm going to take my Desmos calculator. Let me get that ready for us. And I'm going to graph both of these and just find to see where they cross. So let me get that ready real quick. All right, so here is my Desmos. I'm going to go ahead and graph the first one. So y equals ln is under functions, miscellaneous, and it's down here. Okay, so ln of x, so there it is. And I'm going to graph the other one. So x plus y equals 1. Okay, and it looks like this one looks something like this. So you can see that the point of intersection is right here at 1, 0. Okay, so for my solution here, I'm just going to do a really quick little sketch of what it kind of looks like. It's 1, 0. So here's 1, 0. And the graph does something like that. And then something like this, where this is a line and this is your curve. Okay. For this, what I am going to require you to do is check it. Okay, so this is our answer. Yay, 1, 0. Here's a solution. But I want us to check it. So for the check, remember we take our equations, y equals ln of x, and then x plus y equals 1, and we just plug those numbers in. Okay, so my y is 0, so 0 equals ln of 1, which is true because ln of 1 is equal to 0. In case you forgot, you can check it, look it up, it's in your notes. X plus y would be 1 plus 0 equals 1. So 1 equals 1. So it looks like our solution is in fact 1 comma 0. Easy as that. Okay. The last thing I'm going to have you do is just copy something really quickly. We have graphical interpretations of solutions. It's actually part of another, I think it's 7.2, but I think it's appropriate for this one as well. And basically, these are the 3 types of solutions that we're going to see. We're going to see one solution where basically you have 2 lines and you have 1 intersection point where the slopes are different. Okay, slopes are different for this one. In other words, one's going one way, one's going the other. And sometimes they're both going the same, but they might both be positive, but they're still not the exact same. So they're not the same. We have the infinite solution where you have a line and then you have another line that's right on top of it. Because basically these lines are the same. So you have slopes are the same and your y-intercept is the same. Okay, and the last one is no solutions, which is when you have this one line here and another line that is perfectly parallel, which I need to do a better job of, perfectly parallel. And the reason that is because the slopes are also the same, but the y-intercepts are different. Okay, and that's basically it, guys. If you have any questions, like I said, let me know. This is a review topic, so hopefully it's not too difficult. Let me know.